Hello there everyone, welcome to Cyber Bytes. Today in this video we will be talking about the concept of ASN, that is autonomous system numbers, and their importance in your pen tests and bug bounty engagements. And we will focus on an amazing tool from Project Discovery, ASNmap. First, I would request all the viewers to please do like the video, comment your thoughts about the video, subscribe to the channel so that the video reaches more to our penetration testing and bug hunting community and help them discover ways to get better at their tasks. Before hitting our terminal and me demonstrating you about the tool, let us take a step back and work on our foundations about the ASNs and their significance in our pen test and bug bounty engagements. So the first question is, what are ASNs, or what do we mean by ASNs, and actually what are they? So an autonomous system or an AS is a group of one or more IP prefixes or IP blocks, as we may understand. And these IP blocks or prefixes can be run by more than one network operator or a single network operator, and they maintain a clearly defined routing policy to access or communicate with other networks. So here the example is like AS9498, which is having IP address blocks from the range of 125.16.73.0 through 24 and 74.0 through 24. So two subnet blocks are a part of this AS number. Now these AS number, or you can say these blocks of IP address, are having a defined routing policy on how these will be communicating to other networks over the internet. So that is whole idea in short about an ASN. I will be posting more links in the description if you are interested to know about ASN. I will be giving you that also. Now, why actually we need ASNs? Now, why are we actually requiring ASNs? This is primarily necessary for the network operators to control routing within their networks and exchange routing information from other internet service providers. The representational diagram that has been taken from the website ipxo.com, and it is giving a very simplified view about how an ASN, or you can say, communicates, and why do we have this here. So let me just pull out my marker here and laser marker and show you. So here we can imagine autonomous system 1, that is AS number 1. It can be any number. Now, as we already know from the primary definition, that this AS number can have lots and lots of IP prefixes or IP blocks, and each IP prefixes and block will be having n number of IP addresses. So this is, you can say, like a bunch of IP addresses or a group of IP addresses that form one autonomous system. And this system is having a clearly defined routing policy on how is it going to connect with the external, you can say, systems over the internet, and also internally also how is it going to route. It is also having that policy predefined in there, you can say, network infrastructure. Here the external BGP of this autonomous system 1 will be connected with the another autonomous system 2, and here a use case has been explained wherein another block of IP addresses or prefixes will be internally connecting with each other, like so, and this is actually in turn connected with another autonomous system 3, and basically here we can see the blocks of AS here. So this is a logical representation of how these things are. So if autonomous system 1 wants to communicate with autonomous system 3, it is being done via autonomous system 2, so that is a transit autonomous system. So it is working in between this 1 and 3, so that how the things communicate. And if you can imagine at a bigger level, so over the internet there are lots of autonomous systems, and these autonomous systems will be communicating with each other via their external BGP protocol. So this is how actually you can have a simplified view about the ASN. And now let us talk about why actually we do care for ASNs in our reconnaissance phase or information gathering phase. Whenever now we perform any penetration tests or we are involved in any bug hunting engagements for our clients or targets that essentially have a huge footprint of assets over the internet. So imagine a client like say Google, for example. So we need to look for various techniques for discovering these assets for testing. As we already know that when we work on a huge target which has a strong internet presence, in the form of blocks, large blocks of IP addresses, and these blocks of IP addresses might be having thousands of IP addresses under their scopes. So hence it becomes very difficult to perform a proper discovery of, you can say, assets that are related to our target. And additionally, sometimes it is a reality that organizations might overlook their assets on the internet and might forget some of the hosts that could have been left unpatched or unmanaged and keep them open for any sorts of attack. So just imagine a scenario where you can say there is a lack of communication between the infrastructure teams, and some of the assets have not been documented or have not been maintained on a proper asset list. Then these assets might, you can say, get missed out on their huge infrastructure. And if an attacker finds some of those hosts or systems over the internet, so there is a chance that in case if it is not maintained properly or it is not patched properly, then those assets could become an entry point for the you can say attack or any of the malicious acts that can be conducted by an attacker. Now, to get a proper estimate on probable or all of the assets under the scopes, ASNs can come to our rescue. They will be helpful to us to enumerate and list out all the targets that might be available to us. And properly understanding and gathering information from ASNs can certainly help to give you a better sight on the target organization's assets. Now, to effectively approach the problem of finding relevant information from a huge bunch of IP address space, we need to first understand about the vertical and horizontal domain correlations. When we talk about vertical domain correlation, we usually talk about subdomain enumeration. So here we can consider an example or domain that is existing, that is abc.com. So subdomain enumeration, when we go through that phase, we can get a.abc.com, we might get ab.abc.com, we might also get ac.abc.com, and henceforth. Is basically, you can say, a vertical domain correlation wherein we are finding subdomains and we use common tools like GoBuster, Sublister, Amas, etc. Now, talking about horizontal domain correlation, we refer to another level of domain which is actually related to our target. Say for example, we talk about google.com as our target, then the horizontal correlation in that case would be you are gathering information from Google, that is like youtube.com, gmail.com, blogger.com, etc. So they are related with Google, but they are different domains. So this is the way in which basically ASN would be useful to us when we are trying to enumerate our targets internet footprint and infrastructures. And for larger organizations, this can exist, and depending on the scope that you are given for pen testing or bug hunting engagements, use cases can vary, but this is one of the ways by which you can actually go around and you might say gather information using those techniques. And with the help of ASNs, we can quickly map out the network infrastructure and available IP blocks for the organization, and then perform proceeding steps to individually identify targets and zero in our final list of possible targets for the engagement purpose. However, you can say you should also be aware that this sometimes can get a bit clumsy and it can lead to false positive. There is also a probability, but still this exercise is recommended for bigger networks if you want to have an in-depth look or insight about the target network that you are into. And this usually works nice for bigger networks which have very giant footprints over the internet. So you can say telecom companies, ISPs, big organizations like Google, Microsoft, they are having their own bunch of IP spaces and IP blocks, and under that they you can say assimilate these IP blocks into an ASN, and this from ASN we can gather lots of information. So that is how the things are with the ASN. To simplify our task, we have the tool called ASNmap, which has been recently released by Project Discovery, and this is a Go language based command line interface for quickly mapping the organization's network ranges using ASN information. So as I told, Project Discovery are the creators of this tool. You can visit the website, and this is the GitHub link for this project. And the features that actually ASNmap supports is, the first is the lookup feature. So you can look up from either you supply ASN numbers, organization name, IP addresses, or IP you can say IP addresses, DNS, all this information you can, from this information you can get the CIDR ranges for the lookup that you are finding. It accepts input in the form of ASN numbers, DNS, organizations or IP addresses, and it can give output in a detailed fashion in the form of text, CSV or JSON format. Also, you can use them using STD in and out. That is, you can just chain with other tools also if you want. So that is also a possibility. So let us hop on to the project page of ASNmap, and let me show you some of the features and how actually we can go around and install the tool. Okay, so you can see here, this is the GitHub page for the tool ASNmap, and here are the options that are available. And you can see here, as I told from the description in the previous slides here, it is having these features, and installation is very standard and straightforward. You can install Go language, and it requires Go language 1.18 version or later. And to do that, you can just issue this command. Already it has been issued, and this has been installed on my Kali Linux instance. So this is how I installed this tool. And if you do not know how to install Golang and then this tool, I will just put a link to installation of Go language in Kali Linux, and you can actually follow from there also. And usage examples are pretty straightforward. You can see here it is very simple. Just give the ASNmap command. These are the ASNmap is the command, and these are the options that you can use. So if you want to use it through ASN numbers, you can use the -a option. If you are providing an IP address, you can go with the -i or the IP option. If you are trying to do with domain, so you can go with that also. If you are trying to, you can say, use then switch of org, that is organization string, you can use that also. And you can change the configurations also. If you want to change the resolvers, you can change the resolvers also, and you can do accordingly. And output, as I told, you can save this output to a text file or any other file that of your choice. And this is the format that it is supporting. So it is supporting the JSON output, the CSV output, and if you do only want the IPv6 in your output, so you can put this option also. And these are the standard silent and the version option that you want to see, and the verbose option that is out there. Simple and straightforward options are available, and very easy to use. So let us switch to our terminal and have a demo and see what options and how actually we can interpret the information of ASNmap.
This channel does not promote or promotion any illegal activities. All content provided by this channel is meant only for educational purpose only.
Okay, so we are back at our terminal, and our tool is installed on this folder go bin. And so ASNmap is here. So let us open the help file. So yes, these are the options as we saw on the homepage of the GitHub repository for ASNmap. And we will start with a single IP address, and we have multiple options by which we can get an IP address of any website. You can start with like say dig command, and facebook.com. You can use this option also if you want. You can use this also, or else you can just use the ping utility. So we got the IP address of Facebook, either via dig command or ping or whatever you like. You can use this also. So now let us proceed with our tool ASNmap. ASNmap, we will be using the IP address first. So this is our IP address. And let's have a look what we get. Fine. So we got these two blocks of IP addresses, of which this IP address, that is this IP address, is a part of these blocks. And to get more information on this, let us do one thing. Let us start to take output in either CSV or JSON format, whichever we like. So we'll just go here. Now we can see that output was very limited. We only got the two IP sub blocks. And now to get more information about this IP address on relating to the name of the organization of which this IP address and its corresponding blocks are, you might say which ASN number does it correspond to, and other information. So we can use either the CSV option as an output. So full output we will get. So we'll first start with the CSV, and we'll get the information out here. So in a matter of time, yeah, here it is. So this is the timestamp we got. with the time zone, the IP, you can say the input, which was our IP address that we gave to the tool. This IP address is a block of this ASN number, and this ASN number is owned by Facebook, or country is United States of America, and these are the IP you can say blocks of which this part is. So we got the AS number. From this AS number, now we can actually further dig and get more blocks. These are only 2 blocks, but there are more blocks associated with this AS number. We will see that also. But before that, I will show you how actually we can output this same thing in JSON, like so. And here we will get like this. But this JSON is not beautified enough. So let us beautify this JSON using JQ. So here we are, and let us run this tool and we'll get a proper output for this. All right, so we got a proper output that is you can say appealing and visually appealing. So here you can see which country does it belong, what is the name of the AS organization, what is the AS number, and let us note down this AS number, that is 32934, and let us try to enumerate more IP blocks under this AS number, because these only 2 IP blocks are not actually part of Facebook. We can get more out of this. So let us try to get more out of this, and using the AS 32934. Yeah, so let me just punch in the command here. So let us say AS 32934, and let us go with the CSV output and see what we are getting. So let me just, yeah, now it is okay, and there we go. So here we got a lot of IP address bunches here, and if we want, we can do one thing. We can just output this into, like, say Facebook ASN blocks .csv. so this is our format, and we'll just put it here, or else we can actually change the output folder on my desktop. That is okay. Yeah, we got. So let us you can say more out. So here we are. So we are getting these many outputs. So you can see through 21, and yeah, 0 through 20, 31 dots. So these are the ASN blocks, not ASN blocks, but IP prefixes that are available with Facebook, and especially with this AS 32934 in IPv6 and IPv4 format. And let us take an estimate here just for our understanding purpose. Say for example, I'm talking about this block. So yeah, let us do one thing. I will just quit this out, and let us try to calculate how many IP addresses could be there. So I'll be using the IP calc tool for our this IP address, just to get an estimate on how many IP addresses are there under this. So we'll just be going with the IP calc. Let's see. So it is having, yeah, 510 hosts. That's a class B network, and you can just keep on saving, and you can actually forward it like this. And what else we can do is we can just have a look at the JSON if we want. So yeah, I'll just let go of this, and let's try to see the. So yeah, we are getting like this also. So you can actually programmatically, if you want, you can segregate the IPv6 and IPv4 addresses and use it in your workflow. So that is the flexibility that this will be offering you. Now, another thing that we can try out the same exercise is using the organization name. We can actually also see using the domain name also. So let us try out 1 or 2 examples with this. So we'll be using like this ASNmap. Let us remove this all, and let us say, let us go with the domain facebook.com. Yeah, so this same exercise, same thing, we can actually proceed and go ahead. We got the AS number also this time. Yeah, so we got 32934, 32934. Yeah, this time. So this is how we can actually proceed, and you can pretty much repeat the same operations with other domain also. Another thing that I would like to show you is by the name of the organization. So like this, you can use org, and mind that whatever in the previous example we saw, the organization AS name it is in full caps. So make sure you do the same, because I have tried it with the small letters, so it is not working. So let us go with that, and like so, org, that is Facebook Let us see what we get. Yeah, we got this. So we straightforwardly got all the IPv4 addresses under this organization name. You can do like so with Google also. You can also get if the name matches. Yeah, you got that. So like so you can get the name of the organization. For the name of the organization you will get whenever you try to pull out the whole information about that, and based on organization also you can actually work around with that scenario also. And yeah, now you can also chain up multiple domains if you like, in case you want to go and check for different domains also. That is also a possibility that you can run this in this way also. So like so you can go like using the domain switch minus d switch, you are trying to get information about IP blocks of facebook.com as well as twitter.com. So you can chain them like this if you want. That is also a possibility you can use. All right, so now let us have a look at how we can output this thing in say for example CSV format, or let us do one thing, let us go with the JSON format and let us output this. So we'll come to know that which belongs to Facebook and which belongs to Twitter. Yeah, like so. So we got this in this form. So you can repeat the whole exercise again and again like this. You can also see like we got the example of Twitter here. So we can go with the organization name of Twitter. And let's go with the option of JSON, and yeah. So yeah, we got the detail about the Twitter AS13414 and its associated blocks or the prefixes that we might know. So you can actually go ahead and collect these details, go and proceed with the scanning of these IP ranges, or if necessary to get the details about resolving these hosts. So you can use mass DNS or similar tool that helps in quick DNS resolution. You can use them also. So yes, that was it from my side. So if you like my work, please do subscribe the channel, like the videos, post your comments on what you are liking and what you would like to see. I will certainly work on that. So with this, we come to an end of the video. We will be seeing you in the upcoming videos. Till then, take care. Goodbye.